let's go ahead and start talking about things. So my name is James. This is Co-21A. Welcome to UC Davis. Welcome to class. I imagine many of you are first-year students, but probably not all of you, which is great. Welcome back to campus if you have been on campus before, or welcome to campus if this is your first time on campus. The whole point of this class is to just help you be better at math, to see things more from a maybe different perspective than your instructor, or maybe to help clarify some things your instructor has said. There's a lot of different 21A teachers. I think there's 6 or 7 different ones. Let's take a look. Look at my my dashboard here. Let's see, we have Adam Jacob, Granado again, Molossi, Gorski, who I cannot figure out how he spells his last name. Because like sometimes he spells it with an I and sometimes he doesn't, and it's super confusing to me. Like, why is he doing this? I don't know. But I feel like it's not like someone else is misspelling his name. He is definitely writing his name sometimes with an I, sometimes without it. Anyway, I have noticed this, and it's bothersome to me, but whatever. Burke, and then there's one who I don't have access to their Canvas yet, and I think that's Jacob. No, I've got Jacob on there. It's Varn, Diamond Varn. Thank you so much. Let me take a look to make sure I go with the number as well. Cool. Yes, thank you. So just I know I've asked you to submit this via a quiz 0 as well, but by show of hands, who's in Jacob's class? All right, who is in Granado's section 1 or section 2? Okay, how about Molossi? Right, Gorski, all right, Burke, all right, and I can't remember his name, Dauman, Varn? Nobody. All right, cool. Well, great that the person I don't have access to, no one's in. That makes it really easy. I don't really need access to it. I mean, I don't really need access to any of them, but it's nice for me to see the things that they're doing, because people take a very different approach to teaching this class. I will just, at the beginning here, I will point out Professor Molossi is usually, how to say this in the nicest way possible, usually takes a very different approach than a lot of other people. I mean, I like him. He's a great guy. I think he teaches well. Thank you so much. He definitely has a different philosophy on teaching than a lot of people, but I think it's a good philosophy. But you will definitely, it will feel different what you're doing than what everyone else is doing, at least in the beginning. And I feel like the way he asks questions is also kind of, it feels very like a very indirect approach. Like he's trying to definitely make you think about things so you can understand what's happening, but it might feel very different to you. So I'm not saying you should or should not stay in this class. Like you could definitely sign up for a different class if you wanted to. I'm just letting you know it's gonna feel different. Yeah, I was looking at his first assignment. I was like, oh, this is good. It just seems a little extra. So anyway, I mean, there's no one here that I can say bad things about. I don't really know Adam, Jacob, or Granado, or Gorski. I do know Professor Burke. I think she's great. I think she's really great, actually. So don't feel like you need to change classes, but if you feel like the professor you have doesn't seem like what you want, I don't know how full all the classes are. They're probably all pretty full. But if you are thinking you might want to change, it's better to do it sooner than later, is all I can say. So let's go ahead and talk about this class. There's not a lot to this class as far as the details. It's kind of like, we'll do math, and that's kind of it. But let's make sure we all are on the same page. Also, I often don't pay attention super clearly to the chat. I will try to, but for those of you who are zooming in, welcome. And if you have things to say, you're welcome to use the chat. You're welcome to unmute yourself and say words. If I don't see something in the chat, hopefully one of you will be like, hey, James, there's something on the chat. So yeah. You should call me James, but I understand that you might not feel comfortable calling your teacher by their first name. You can call me Mr. Parmenter. You can call me other things. Professor is fine. I'm not a professor, but people seem to feel comfortable saying that, so you're welcome to call me that as well. As long as I respond, you're welcome to call me pretty much whatever unoffensive thing you want to call me. Got a lot of class. Okay, so let's see. We got the home page here. You all know where we meet. You're here. Welcome. You are also welcome to come via Zoom. So if you don't you don't have to be here, even though you can be here, right? You can come, like if you just aren't feeling like getting out of your dorm or apartment or wherever you live, you can come via Zoom. Or if the weather is total crap, you can come via Zoom. It's really fine. I'm very, right, we've had a whole year of Zoom. I definitely like seeing you here. I want you to be here, but if you don't want to be here on a particular day, it's really okay. Something else I was going to say to that effect. Oh yeah, I've had a lot of practice teaching on Zoom, so I've gotten pretty used to it. This is now what feels weird. I'm like, people again, really? Okay, but it's good. It's a good weird. We're going to use it. Welcome to class. Here's about me. I went to UC Davis many years ago. Some of the teachers I had are still teaching here, which is kind of cool. Dr. Diddell, who's teaching 17A this quarter, had him a long time ago for a math class. He was very good. The syllabus, there's way too much information on here. Here's how you can get a hold of me. Email is probably best. I see it, it comes up on my phone right away. That's probably the quickest, most effective way to get a hold of me. Office hours are also in person. And so I have in-person office hours before class on each day, like from 9 to 10, starting next week, right? Because today's over as far as that's concerned. And also on Monday and Friday in this room from 11 to 12, it says right there. Yes, great. And then also I do have virtual office hours Tuesdays and Wednesdays from 3:30 to 4:30. That might change, it might not. You can also, if you're looking for extra help, make an appointment with me on Calendly, and that would be a Zoom appointment. We might try doing those in person, but for now they're at least I'm thinking they'll be on Zoom, because that way it's easier to actually see me. Like you don't have to go to a place to have help. And if you click on that link, you'll see. Let's go ahead and click on the link and see what we see. Yeah, you're so annoying. I need to fix that, because that's definitely okay. Let's log in. Oh, well, maybe we'll try to log in here. I don't actually know if I know my my password. Let's find out. Yeah. Sure. Let me in. Great. Yep. You guys get to see all of this. Duo. Okay. It seems funny when you log in with some. Oh, welcome. May I see your symptom survey, please? It seems silly with Duo, like when you log into something on your phone, you're like, nah, I'm going to do it again on my phone. Like I already have my phone. Obviously, it's me. Cool. So Calendly. Yeah. Well, clearly I need to fix a link, but you can look at my calendar. Thank you so much. Appreciate it. And if you click on a day, you can see. Usually I'm available, like just kind of there's not a ton of availability because I'm fairly scheduled doing a lot of other things, but I'm typically available most days from 1 to 1:30-ish. So if you want to make it an individual appointment with me, you certainly can. You can also make an appointment with another student if you want. Also, you should definitely study with each other. You're kind of each other's best resources in this class. So if you're looking for help, there are lots of places to get it. There is, I don't know. I don't know what the right grammar is. There is not a grammar class. This is a math class. What else? Yeah, there's a lot. I'm just kind of like, let's look through Canvas and see what there's. Hopefully you all have looked at Canvas and explored what there is to see. Attendance is how you pass this class. Just come. It's really like, that's it. Like there are optional quizzes, literally optional, right? You do not have to do any of them. I would really appreciate it if all of you did the quiz 0, just because it's a quiz where you tell me a little bit about yourself, and it also gives you practice using Gradescope, which is something I imagine some or all of your, not all, but certainly some of your classes this quarter or future quarter will probably use. Did I see a raised hand?
Are you going to help us calculate the grades too? Because the professor expects us to know how to calculate the grade average overall.
Sure. Yeah, we can do that. It's a good math problem. Usually, like I'm assuming they're telling you like your grade is some percentage homework, some percentage midterm, etc.
Yeah.
And they want you to calculate it yourself. Yeah, you can totally do that. I thought I saw another hand back there, but okay, I'm just imagining hands. It's all right. I see people like sometimes do like this. I'm like, oh, so yeah, but as far as this class, you will know if you're passing or not because it's just based on attendance. So you have to come literally 75% of the days. You should come every day. I think we meet, I don't know, we meet some number of times. What, there's 10 weeks plus today. So like 21 meetings minus a couple for Veterans Day and Thanksgiving. So I think we meet 19-ish times, which means you probably have to come 15 of those times. So you can miss 4 classes, I think, approximately. But come every time. Also, you can also come via Zoom. And I mean, really, if you needed to not miss class, you could come via Zoom, not be on camera, and sleep through class, right? I mean, I would never know the difference. I would assume you're, or you can actually watch I will also post the recorded videos afterwards. So everyone should pass this class, right? It's not a hard class to pass. The point of the class isn't passing or not passing. The point of the class is getting more help with math. So warm. Okay. There are weekly optional quizzes. Let's go ahead and take a look at grade scope just so we can see them over there. Grade scope. Let's see if I'm already logged in. There we go. So there's all the quizzes. Oh, some of you have already done quiz 0. Excellent. You can look at the outline. You should always be able to see the PDF of the quiz in Gradescope. It will also be in Canvas. So here's the first one, just asking about you, what your name is, what your hometown is, so on and so forth. And also then giving you the ability or the opportunity to practice assigning questions. That's the thing. So in Gradescope, the one thing that you need to be aware of is how to assign questions and pages. It's easy once you do it a couple of times, but at the beginning you're like, oh, there's this thing I have to do. So just do the first assignment, but the quiz 0, I should say, and it should be relatively straightforward. I also have somewhere in the modules, there's a couple intro videos about how to submit work in Gradescope. So if you're not sure, watch the video. It's pretty easy to understand. Like it took me a little bit at first. I'm like, how do you do this thing? I was like, oh, okay, it's fine. Yeah, and then there's some actual regular quizzes, like with math on them, I think. Now I'm not sure if I've actually even, let's see if there are any quizzes yet. They're not available yet, but let's see. Okay, yeah, there's some actual quizzes. Great. So there'll be quizzes there. They are old quizzes, but they should align relatively well with what's happening in the course each week. And I will certainly look at them before they become available to make sure that they actually make sense to be assigned. I will probably modify some of them. I'll probably leave some of them as is. And then, is there anything else in the syllabus I wanted to mention before we get to the modules? Quizzes, I will post the videos and I'll post them on YouTube, and I will also have link to them from Canvas. The class notes, which I imagine I will be writing here momentarily. I will also post those in a Google Drive folder, and you will have access to that very easily. And then here's a place where you can get more help. There's a website I'm going to add, which is Grant's website, which eventually, I haven't added it yet because currently, but I will say Grant's a great guy. He is one of the other specialists here. And his website, he had to redo all the links because Google changed some things. So he's been redoing all his links. And once his 21A links are live, I encourage you all to utilize his website because he's got some good notes. I won't lie, I typically use his notes as inspiration for what I'm going to say in class, but currently you can't get to them because he hasn't fixed them yet. So once that is available, I will link it for you. It's definitely a useful resource for 21A, 21B, 21C, 21D. Oh, that's the thing I would say. Yeah, interesting. I wonder what's up with that link. I have to look into that later. All right. One thing about the book, you all want the book. I know for Professor Malassi, he has said there is no book for the class, for his class anyway, but like you don't need to have the book. You still should get the book because even though you might not need it for 21A in his class, it's the same book for 21B and 21C and 21D. So you should get the book. I personally like having a physical copy of the book. I think somewhere, I'll take a look. I think I have a PDF copy of it somewhere that I can definitely post on Canvas, even though I'm probably not supposed to, whatever. But I also like having a physical copy of the book. It's nice to actually look at it. So if that's your style, you should do that. If it's not, you should use a PDF. But it is a useful resource. It's a decent book. I mean, I've read better calculus books. I've read worse calculus books. It's perfectly fine. I guess maybe not worse, just, I don't know, worse. I've definitely seen some worse books. Like they just didn't feel like they were thoughtfully laid out, or the examples were not like it. There are definitely some books that are just not that good. This one is perfectly fine. Let's look at the modules. The modules have some very basic information, the getting started stuff. I think we've all done the daily symptom survey. We know how to do it. You showed it to me. Oh, great. We'll do that every class. So fun. Or not, but it is what we're going to do. Here's the link to the Google Drive folder where you will eventually see class notes. There's literally nothing in there because there aren't any class notes yet. Back to the modules. Just trying to, like, I know this might feel like maybe a little bit of a waste of time, but we got lots of time. So it's all right. We can waste a little time. First day, you're like, yeah, we'll just chill. Here's all the problem solving sheets. This is also where I sometimes take inspiration from problems. It is, so typically the way this particular class usually goes is, at least in the past, I've said mathy things for the first half-ish, and then the second half, I will give you problems to work on individually or in groups. I feel like we should still do that. Like that seems like a good thing. So, I mean, really, I could talk all day about math, but honestly, the way you learn math is by doing math. At least, I mean, it's good to see things shown, right? It's nice to have instruction. It's important to see how to do new things, but also practicing it is how you're going to get better at it. So I think we're still going to do that. So I'll try to say math things for the first hour or so, and then I've got problems for you guys to work on. And I will definitely be here, circulate, look at things, help you with things. If you have questions, but you should also work with each other. I mean, I feel like, right, we're already sitting close to each other anyway. I don't think it's too uncomfortable to work with each other. I hope. Here's what I'll say. You don't have to work with each other, but you are certainly welcome to. You can all work individually. You can spread out. I mean, there's not much more with this spread out really, but you could spread out if you want to. You can also work in groups of 2 or 3. That's perfectly fine with me. Do whatever you feel comfortable with. And so you can access those there. I also have made copies of it, which I will hand out to everybody. Extra problems. There's extra problems. Oh yeah, there's a derivative worksheet, which we will definitely look at when we get to doing derivatives. Here's old videos I made last year that you can watch if you really want to. They're not particularly exciting, but they are informational. Quizzes and quiz solutions. You can't see the solutions yet. So that's one reason why I will probably, if I can, try to reuse the quizzes, reuse them, because I've already written solutions to them. So that's definitely a reason to reuse them, but I will also modify them if I need to. And then some useful handouts. Oh yeah, these are good. We'll definitely talk about these limits when we get to them. I guess I should ask, so everyone's had one class, right? Everyone had class yesterday? Okay. What'd you guys do? Like, what's that? Syllabus? Did anyone do like any math yesterday? Okay. Did you guys talk about functions? Putting the sign in functions? All right. We talk about functions, yeah. I guess I should, before I get carried away with the math, I suppose I should ask, do you guys have any questions? About anything? This class, other classes, Life and Davis, me personally, yeah.
I just noticed on the quiz there that it said there was a question where it asked your favorite food and it repeated twice.
Sometimes I make mistakes. Yeah, you can write it twice or you can write it once. Yeah, that's interesting. I did not notice that. Let's take a look. I'm curious. I mean, I believe you. I'm just surprised that. Oh yeah, favorite food. I mean, food's important, right? You put your favorite food, your favorite. Yeah, I bet all of you probably have more than one favorite food. Feel free not to answer twice. Yeah.
So are we going based off the quizzes or by like the lectures?
But
Like the material we're going over?
so the material we're going, so the quiz is totally optional. I will certainly, if you want me to address them in class, I will talk about them at length. My intention is not to cover them at all in class. So the whole point of the quizzes, in my opinion, is if you want feedback. So, right, a lot of, and actually I feel like things have evolved in a positive way lately. I was looking at a lot of the 21A teachers, and it looks like a number of them, not all of them, but certainly Gorski, and I feel like at least one other person said they're going to be having you guys submit things via Gradescope and actually grading them, which is nice because I feel like a lot of the time in previous classes, students have been pretty much just the only things that were getting graded by hand were exhibits, and everything else was by work, which is certainly a great tool, but I feel like it doesn't always give you much in the way of feedback as far like you just have to keep trying until you get it right, and you don't really necessarily know. You don't get to see why you might be making mistakes. Like I feel like it's a good tool, but it's not perfect. So the whole point of the quizzes is if you would like to get feedback on your work and practice doing the work, that's what they're there for. So you can all do the quizzes or you cannot. Right? They're literally not required at all. You don't have to do them. But I think you should do them because if you do them, I will grade them and then you will, and right, the grade counts for nothing. Right. I will grade them so you can read the comments in Gradescope about what you did correctly or not correctly. So that's kind of the whole deal. So I encourage you all to do the quizzes once they become available. I think they're due on Mondays, but if you did one late, that would be, well, actually, I feel like Gradescope might not let you. So I can, if you want to do an old quiz that has become unavailable, just let me know and I will make it available. Or I'll just change all the dates to be due at the end of the quarter. Or I guess I'll change the late date to be due at the end of the quarter. So that way you can do it, but it'll still show that it's like due on a certain day. Because it makes sense to do them in a timely fashion since the material, right? They're designed to be covering the material that's happening that week. So yeah, hopefully that answers your question. So in class, I will go over notes I have, talking about domain and range and all kinds of stuff today. And then I will paper jams. I have to talk to myself. I think I've gotten used to talking to myself a lot because I was literally, right, as we all were, I was in my office at home talking to students on Zoom who most of the time didn't have their camera on, just kind of like, okay. So I've gotten kind of used to be like, hey James, what's going on? Oh yeah. So, and I'll give you these problems to work on after we cover some math. Other questions? Just like wait. Make sure everyone's in then. What time is it? It is 10:27. All right. I said you should call me James, right? Covered that. Okay, call me James. But if you can't, I totally get it. I definitely got my master's degree at the University of Colorado Springs, and then ended up working there afterwards. And it was definitely weird, like having colleagues who were my teachers, and most of them I was able to call them by their first name, but there's definitely like one or two guys I was like, no, you're just Dr. Chakravarti. I can never call you by your first name because, but also because it was just weird. But he was not the nicest. He was not the most understanding of professors. He was definitely, yeah, he was very much, I'm going to point out all your mistakes in class in front of everybody kind of guy. It was not endearing at all to anyone. And not a very effective teaching method either. Like other things that, right? If it's effective, fine, but it wasn't. So yeah. All right. I think we've covered all the things. I will try not to swear too much in class, but hopefully everyone's okay with a few swear words. Because if you're not, let me know. Like I can definitely not swear, but we're all mostly adultish here. An occasional swear word is not going to kill anyone. But really, like if it is offensive to you, let me know, and I'll just try not to. Occasionally, though, things slip out. My nephew, who is 7, started going to an after-school program with children of various ages. Some 6th graders, I think, came home from like the 1st or 2nd day and was like, "Mom, I learned a bad word." It was the S word. And he asked her what it meant, and she told him, and they talked about how people use it. And then he saw, and I heard there was another bad word too, a really bad word, the F word. And she said, then they talked about the F word. He asked what it meant. She's like, it means lots of things. It sounded very amusing, and the reason why I'm really glad I'm not a parent. Kids are great. Other people's kids are even better. Okay, let's see if I can get this dialed in here. I feel like I want is that I want something in between those two. Can I not zoom back out? Is this no longer an option? Okay, there we go. Let's see. Let me try. Sorry, I know this is. I don't love the. Okay, there we go. Let me do this. Let me do that. Yeah. Cool. Can I really? Are you going to be like that? Okay, that seems all right. Let's see if we. Do I want to maximum? Oh, I want to share this. I'm sharing the whole screen, right? Yeah. Okay. I guess I should do it this way so that I can still see the chat in case people want to chat things. Let me ask you all. Let me write some things down, and then we can talk about if it looks like terrible or if it looks okay. So let's look at some stuff. Oh, my hands feel like a little like shaky. Weird. Maybe I drank too much coffee this morning. I think that might be the case. Let's go ahead. Oh yeah. So feel free to move around. Like if you're over there and you don't feel like you can see the screen very well, feel free to come over to this side of the classroom. We definitely have plenty of space since there's only like 15 of us. But let's go ahead and look at something like this. So here's a function. Here's a piece of a function. Now let's say this. So this function. Oh, let me do that. That's terrible. Okay. Also, let's see if we can make this a little. Oh, holy smokes! That is not the button I meant to press. And technology. I mean, technology is great, but sometimes it's interesting. Like this really like zooms in, no problem, but it really does not want to like zoom back out ever. There we go. Okay, you have to press it like 5 times. So let's talk about things, some basic things. So domain, just the x values. We could say that x is between 1 and 7, or typically people like to use interval notation when we talk about domain. So it would be bracket 1 to bracket 7. The brackets indicate you're including an endpoint, parentheses indicate you're excluding an endpoint. The range here, which is the y values, is going to be everything between 2 and 8, or in interval notation, bracket 2 to 8 for the bracket. And we'll definitely talk more about domain. Yeah, question. Oh, and I should just, pardon me, you should feel free to ask questions like whenever. So don't, like if something is not clear, confusing, I've written something terrible, I made a mistake, I make mistakes, that happens. Please, please don't hesitate to point it out or ask me to clarify something.
Did you say parentheses meant including?
No, parentheses mean excluding, and brackets like this mean including. Okay. So just as another example, if let's say we had, oh yeah, let's do this. Let's say our function looked like, let's go there, and let's say, let's just make some numbers. So this was the piece of function we were looking at. This would have a domain that, well, we don't get 3, right? We're excluding 3, and we're also excluding 6 because that point is not included. So the domain would be everything from 3 to 6 exclusive, or we could write it as 3 is less than x is less than 6. And our range would be everything as low as 2, but excluding 2, and as high as forever. So from 2 to infinity. Or the way we write the range is just y is greater than 2. You wouldn't write it was less than infinity. You don't need to. It's implied if you're saying y is greater than 2. You can just keep going and going and going. I should mention, infinity is not a real number. It's more of an idea or a direction. So it is not something that ever gets included in an interval notation because you can't include the number infinity. It's not a number. That said, we all the time talk about like multiplying infinities together or adding infinities together. So we, even though infinity is not a real number, we still kind of, we treat it like a number sometimes when we talk about how to play with it, but it is not a real number. Yeah, good question. So many things. Try to be organized, but yeah, it's the beginning of the quarter. We'll talk more about domain range in a second, but let's talk a little bit about. Oh, and if I'm going too fast, let me know. I can certainly slow it down. I can also, if you feel like you've missed something and you don't want to say anything because you're like, I don't want, that's also cool. I'm going to post the notes on Canvas or on the Google form, which is a link to on Canvas, moments after class, because all I have to do is scan them and literally send them to Google Drive, right?
Wait, is it 0, 0 or just 1, 0? The range 2/0, 0.
Oh, that's not 0, 0. That's the symbol for infinity.
Oh, I think.
Yeah. So infinity, right? Looks like that. Or some people like to say it's a sideways 8. That is also people. Well, actually, I remember there's some dumb TV show I used to watch. I don't remember what it was really like, but I remember the guy would call infinity upright 8, or sorry, he would call 8 upright infinity. And I was like, that is the dumbest thing I've ever heard, but it is also memorable. So yeah, sideways 8, upright infinity, whatever. Even and odd functions. And we're just kind of, for the moment, taking a scattershot approach just to kind of cover some basic things you should be aware of. Don't feel bad if you are like, if this seems new to you, that is also fine, right? I'm going to try not to make the assumption that something is, I feel bad saying like, this is a basic thing, like ignore my dumb words sometimes, right? If you're like, I've never heard of that, that's all right. It's really okay. I should just say, I don't know. I should try to use different language, I suppose. So even and odd functions, here are some kind of classic examples. F of x equal to x squared is even because, well, so the way you test a function to see if it's even is you check to see that f of negative x is equal to f of x. And that has to be true for every value. So it's not sufficient just to check it for a couple numbers. You could certainly do that and say, oh, well, look, f of 3 is 3 squared, which is 9, and f of negative 3 is negative 3 squared, which is also 9. If someone asked you to show this function is even, that would not be enough. That would certainly be evidence. Like, oh yeah, I think it's even. Look, there's one example of it being even, but to actually show it's even, you have to show that, and it's not like super hard to do. We say f of negative x is, instead of x squared, it's literally negative x times v squared. The negative x squared is negative x times negative x, which is positive x squared. And just as a reminder, right, when you square something, you're literally just multiplying it by itself. Now, that's how you show a function's even. But what does it really mean to be even? Well, one of the hallmarks of evenness is that you have symmetry about the y-axis. So if we draw the graph of f of x equals x squared, it looks like this. Oh, wow, that's not my best job ever. That is, okay, let's try that again. Sometimes my graph, so this is an excellent time to point out that there are excellent graphing devices available to you that are not just drawing by hand. So let me write some things here. So this is f of x equal to x squared, and you've got points like 1, 1, and 2, 4, and -1, 1, and -2, 4. But I would say you should not do a lot of graphing. And certainly you should know how to graph things, be aware of graphing things. But I will also mention that, and I would imagine most of you are probably aware, that Desmos is an excellent graphing device. You can see all sorts of cool things. You can also make graphs that don't look like total garbage. So we can see this function's even, and it's kind of actually cool. You can even really see the evenness of it by writing, there's literally substituting in -x for x. Oh yeah, it's the same exact function, right? They're the same. I mean, I don't feel like I need to do this, but right, you can see that. So that's kind of cool. Desmos is great. We'll come back to that in a minute. Anything else I want to say about even? Nope. Actually, yes, I want to write down, we have symmetry about the y-axis. All that means is that if you reflected this graph across the y-axis, it would look the same. All right. Odd functions. One thing, so I will say, yeah, it's too bad. The one thing that's nice about writing on the board, which some people used to do before we had document cameras, was that you could still see the things I'd written while I started writing new things, but it's not really an option here. So there it goes. Bye. Again, I'll post the notes on Canvas if you want to see them later. What does it mean to be odd? Well, here's another example. F of x equal to x cubed is odd. Let's graph it. This is when I'm always terrible at graphing. So let's try our best. We get points like 1, 1, and 2, 8, and -1, -1, and -2, -8. And it's odd because f of -x is equal to negative f of x. We can check numbers, right? F of -2 is -2 cubed, which is -8. And f of 2 is 2 cubed, which is 8. So we can see that, oh yeah, f of -2 is indeed equal to negative f of 2. Again, I want to mention, this would not be enough work to prove or justify to someone that the function is odd. It's good evidence, but it's not complete. To show it's odd, we are actually going to show that f of -x, well, I'm just going to take my function x cubed and substitute in -x for it. And then -x times -x times -x is negative x cubed. I know it sounds like I'm saying the same thing, right? Here's -x cubed, and here's negative x cubed. I try to put the pause in there so you can hear where the parentheses are, or you can literally just say print the -x quantity cubed versus the negative of x cubed. And that is equal to the negative of the original function. That is how you would actually show the function is odd, or demonstrate to someone else that you can show that the function is odd. Yeah, this is called, I should say, odd functions have what is called either rotational symmetry, also called symmetry about the origin. And the way I always think of it, the way I literally think of it is if you rotated this 180 degrees about the origin, it would look the same. Another way to say it though is if you reflected it both in the x-axis and the y-axis, it should look the same as it originally did. And again, if we look at Desmos here.
Professor, I have a question.
Oh yeah, go ahead.
I can't read it as well. Okay. Like what does the graph say that in the middle? Like the points on the
Right here?
The center, no.
These ones here?
Yeah.
So this one, yeah, you're right. So also please let me know in general. Sometimes my writing is not the best, not gonna lie. This says -2, -8. This is -1, -1. This is 1, 1. This is 2, 8. Yeah. It's an excellent question. We will look at that next. I like it a lot. Oh, what I was going to show you is if you look at Desmos here, we can graph f of x equal to x cubed, and then you can also graph. Right, if we plug in the negative of x, it's literally rotating it 180 degrees. Now, oh, sorry, it's not, right? So it looks like I've just done the reflection. So I actually need negative of the negative, right? So it's kind of, I feel like I'm kind of doing it a little bit wonkily here. What I really should be saying is, let's do this. I wonder, I'm curious. Let me see something here. Cool. Yeah. So if you already have written something for f of x, so there's negative f of x, and here's f of negative x. And if we unclick a couple of these, I don't really like you anymore. Go away. Right. Negative f of x and f of negative x are the same. Kind of cool. I think it helps us see things. So if you haven't played with Desmos, you should. It's a great tool. Most of your professors will probably assume you are using it or are aware of it, so you should be aware of it. Someone last class asked me if they should get a graphing calculator, and I was like, well, I mean, you kind of have one. It's your phone. There's Desmos on your phone. That's probably, I'm really like, you can buy a TI-83 or 4. Those are also great tools, but I feel like you're spending money you don't need to spend, right? This is there. It works really great. So I would encourage you all to use this unless there's a very specific reason you need a graphing calculator. Yeah. So to answer your question, or to address your question, because I think it's a really good question, how would we show that f of x equal to the absolute value of x is, well, what is it? Is it even or a dot? It's even, right? Because I mean, if you think about the graph, right, it looks like this. Right, we can definitely see it has the hallmark symmetry about the y-axis that is for even functions. Also, we should take a break, like an hour in, because I will definitely use the bathroom and refill my water. So if yeah, there used to be a clock in here, but I think it broke. I'll try to pay attention to the time. And if you notice it's like 11:10 and I haven't said let's take a break, you should be like, hey James, we should take a break because I will need to pee. Because I'm old and I need to pee all the time. It happens when you get old. So the way you show this function is even, well, you have to actually know what this function is. So the thing about the absolute value function is it's really just an abbreviation for a piecewise function. There's there's two ways you can write the absolute value function. The way you should all be aware, should be aware of both actually. Meaning not that you should already be aware, but you should from now on be aware after we see it. The way people usually write the absolute value function is the piecewise function where the absolute value of x is x if x is greater than or equal to 0. Right? If x is positive or non-negative, really, the absolute value of x is just x, right? The absolute value of 5 is 5. The absolute value of 7 is 7. The absolute value of 0 is 0. What about if x is negative? What's the absolute value of negative 5? 5. What's the absolute value of negative 3? Right. And so the absolute value of x, if x is already negative, is negative x to make it positive. Which always feels kind of weird because you're like, wait, it's negative. No, it's not negative, right? It's actually positive. We're taking the negative and making it positive. Yeah.
Isn't there supposed to be a 0 between x and 20? down there? X is 20.
Oh, so sorry. This is if x is greater than or equal to 0.
Oh, greater.
Yeah.
I don't see the greater sign here.
So
I see it now.
yeah,
X, yeah.
but please don't hesitate to ask questions. Like I know my writing is not always very clear. So we could do it this way, right? We could say, well, I'm going to try and show that f of, so this is actually going to be a little bit challenging. We want to show that f of negative x is equal to f of x. All right. I feel like we kind of have to do this case by case. Right. So we're going to say if x is positive, then negative x is negative, right? So f of negative x is going to be, this is going to be interesting. I have, okay. There's another way to do this, which is easier, but I feel like this is more illustrative. F of negative x is going to be the absolute value of negative x. And the absolute value of a negative number is the negative of that number, which is x, which is equal to the absolute value of x, because x itself is positive, which is what f of x is. So we got there. We got to, where's my red pen? This feels like, I feel like it's a little bit double speak almost, like we're just saying kind of the same thing over and over again. But we got to what we wanted, that f of negative x is equal to f of x. But we haven't exhausted all the cases, right? We've only looked at when x is positive. We also have to look at when x is negative. Yeah.
Can you explain the if part again? Like how?
Sure. So the thing is, I'm breaking it down into cases because what the absolute value does depends on if x is positive or if the insides are positive or negative. So I'm first looking at the case where x is positive, so that the insides are negative. But now we're going to look at the other case, which is where if x is less than 0, then negative x will be greater than 0. And then f of, because ultimately we're trying to show this, right? That's what we're trying to get to. That no matter what, so, and here's why we have to do all the cases, because we have to show that whatever you pick for x, f of negative x is equal to f of x, right? That is the definition, literally, of being an even function. So we have to show that it's true for every value of x. So if x is less than 0, f of negative x is positive, and f of negative x, which will be the absolute value of negative x, well, since the insides are already positive, the absolute value of a positive number is just that number. So that's just going to be negative x. And now I'm trying to get to here. If x is less than 0. Come on, brain. Is this equal to f of x? I don't think so. No, it's a good question. I'm really like, I'm not like just discounting what you're saying. I'm saying like, I really don't think it is. Let me think about it. So if x is negative, then negative x is positive, right? And the absolute value should always spit out a positive or a non-negative, positive, right? And so it should be spitting out negative x because the negative x is already the positive number. But then I want to show that this is equal to f of x. Oh, okay, but that's okay. It's going to work out. Yeah. So let's just write it over here. I guess we can work backwards. F of x is equal to the absolute value of x, but x is negative. So the absolute value of x should be the negative of x. And that works. Tricky, right? It feels tricky. I gotta make sure I don't like, I always want to go over there. Okay. And then you can either do it for 0 as well, right? Because we haven't checked 0, or you can just be like, right, you could throw in some bigger, less than or equal to, greater than or equal to, that would also be fine. Yeah.
For the absolute value, why would it be negative?
Right here. So we've got two different cases. The first case is when x is positive. And so then the absolute value of x is just itself. But in the second case here, we're saying that x itself is a negative number. So imagine, this is actually a good thing to do in general. If you're not sure if something works like with a variable, plug in a real number. So let's pretend that x is negative, so let's pretend that x is -6. So f of -6, right? Because x is -6, so negative x is negative -6, which is positive 6. So f of 6 is the absolute value of 6, which is 6. Right? So if we pretend that x equals -6, then negative x is equal to positive 6. And then it works, right? F of 6 equals the absolute value of 6 equals just 6. So that's why it's working there, because x itself is a negative number, so negative x is a positive number. It's a tricky question. Let me show you another way that's an easier way to think about it.
Then how did you get negative x after that? Like, how
Well, so I work back from the right side. So I don't need this extra negative x here. I could have just jumped to here, but I was having trouble making my brain see that negative x was equal to the absolute value of x. But it is, because, well, again, let's think about it this way. X is negative, and the absolute value of a negative number is the negative of that number. So the absolute value of x is equal to negative x, because, right, let's just continue with the -6. If x is -6, what's the absolute value of -6? 6, which is negative x. So yeah, that's a little tricky. I thought it's a really good question. Thank you. But there is so I encourage you all to think of the absolute value this way, because it comes up a lot. It's going to come up when we talk about the definition of derivative, probably, because it's a pretty classic example. And also when you talk about integration next quarter, people will have you integrate things that are like absolute value function, and you have to be able to break up the absolute value function into its multiple pieces. So you always want to be breaking it up into, okay, the absolute value of some stuff is just the stuff if the stuff is already positive, and it's the negative of the stuff if the stuff is already negative to make it positive. That's how I always think about it. And just to kind of expand on that a little bit, for example, the absolute value of x minus 2 is just going to be x minus 2 if x minus 2 is greater than 0, and it's going to be the negative of x minus 2 if x minus 2 is less than 0. And you can put the equal sign on either part. But it's always just like whatever your stuff is. Oh, sorry, you guys can't see that very well. If the inside's positive, leave it alone. If the inside's negative, multiply it by a negative to make it positive. And let me wait a minute, get some water. And I know I promised you another way of seeing this. So there is another way to see the absolute value, and it's kind of cool. Here it goes. Okay. Sorry. Sometimes I can be ridiculous. Also, that's better. You can see the whole thing now. What's the square root of x squared? Well, sometimes. It's the absolute value of x. If x is positive, sure, square root of x squared is just an x. But if x is negative, square root of x squared is also just negative of that x. Let me show you an example. What's the square root of 5 squared? Right. I mean, it's not a trick question. What's the square root of -5 squared? Also 5. We know another function that does that. where if you put in a positive number, you get the same number out, but if you put in a negative number, you get the corresponding positive number out, and it's the absolute value function. So it's really actually this fact does come up often, that the square root of x squared is not just x, it is actually the absolute value of x. It's x if x is already positive, but it's the negative of x if x happens to start out being negative. And we will definitely see some examples of limits that abuse this fact.
So you can never have a negative in that square root.
Well, right. So there's a couple things. Yes, there's a couple things to see here. We can't take the square root of a negative. Right? The square root of -9 is an imaginary number, and typically we don't deal with imaginary numbers in really any of the 21 series. Is imaginary. You could say, if you wanted to, the square root of -9 is equal to 3i, where I is the imaginary unit, the square root of -1. But we're not going to worry about that, right? That doesn't come up in this possibility at all. It might come up, I feel like maybe it comes up in 21C when you talk about series a little bit, but usually you don't really see that until you take, I don't know, actually. I'll have to think about that. But another thing to be aware of is the square root of 9. What's the square root of 9? Just 3, right? Not plus or minus 3, just 3, which is, I'm glad you all said, I'm glad I didn't hear you plus or minuses. It's okay if you're thinking it. I know you're like, well, but seems like, what if we're solving this? Well, the solution to that is definitely 2 solutions, plus or minus 3. But right, if you're solving this, you're really taking the square root of both sides. What's the square root of 9? You already told me, it's 3. What's the square root of x squared? Thank you, yes. And if the absolute value of x is equal to 3, that means x is equal to positive or negative 3. That's why we're getting 2 solutions, because of how this works. This is always something that, like, when I first learned it, I was like, oh, that's kind of confusing. Like, it's like we get so used to thinking of a square root as kind of being one of 2 things, but really, there's actually a lot of functions like this where technically we could have defined it in a different way. And we'll talk about this for like trig functions and inverse trig functions as well. But the mathematical community has kind of all decided that when we talk about a square root of a number, we are only talking about the positive square root. And a lot of that's because we want this to be a function. And when we talk about the square root of x, we want for the, well, I mean, we want for the graph to pass the vertical line test, right? So when I take the square root of 0, I get 0. And when I take the square root of 1, I only get positive 1. When I take the square root of 4, I only get positive 2. Right, if we had the, in fact, this is a great time for Desmos. Desmos, I mean, my graphing skills are, they're fine, but it's nice to be able to see really like nice graphs of things. So here is the square root of x, SQRT, yeah, that's what I want. And here is, if I square both sides, there's kind of the whole thing. And they're different. Right? Y squared equal to x is a different graph than y equal to the square root of x. Because when y squared equals x, or really, we would probably think of it as x equal to y squared. Whoops, I didn't mean to delete all of that. Well, I'll close that door. When you're graphing x equal to y squared, y has the option of being positive or negative. Whereas when you're graphing y equal to the square root of x, since we've all decided that the square root of x only gives us positive outputs, I should say non-negative outputs, because you can have the square root of 0 being 0. You only get positive, non-negative y values. So that's the difference. And we have made this choice because we want this to be a function. We don't want to have this garbage down here that would make it not be a function. Yeah.
Can you explain again how it's possible that it is positive or negative 3?
Sure. So yes. So these 2 things are different. So this is an equation that has multiple solutions, right? And I think it's clear that x could be 3 because 3 squared is 9, and x could be -3 because -3 quantity squared is equal to 9. But when we're solving this equation by taking the square root of both sides, right? So typically, if you were solving this, and you should, most of you, myself included, would jump straight to saying x is equal to plus or minus. You might write the square root of 9 if you're writing it with that, but you might just jump straight to x equal to plus or minus 3. And the point I'm making here is that the square root of 9 itself is just positive 3. And we are tacking on the plus or minus because we know there need to be 2 solutions. So that's why we're getting the plus or minus. It's not because the square root of 9 is equal to plus or minus 3 itself. It's actually because the square root of 9 is only equal to positive 3. And we need the plus or minus to indicate that there are 2 different solutions to this equation. And we're
Like in case the square root of 9 is -3, then.
so I want to stop you there. Square root of 9 is not negative.
Or,
Square root of 9 is only positive 3. But the difference is we're not saying this, we're solving this. And this equation has both solutions, x equal to positive 3 and x equal to -3. Or said another way, x equal to positive square root of 9, which is positive 3, and x equal to the negative square root of 9, which is the negative of positive 3.
so in case the solution for the square root of 9 is the -3, then the negative is there. to turn it.
So I want to clarify some language. Square root of 9 is not an equation. The square root of 9 is just a thing we're doing to 9. Whereas this is so right, when I write, come on. When I write the square root of 9, that's just the number, and it's 3. When I write x squared equal to 9, that's an equation I'm trying to solve. And I'm trying to find all the solutions, which there are 2 of, 3 and -3. But I want to be very, very clear. When I solve this, we solve it by, right, the fast way is just saying, oh, x equals plus or minus square root of 9, which is plus or minus positive 3. Square root of 9 is only positive 3. And the reason that's true is because of what we said before, because of all this. Because when you solve this, you're taking the square root of both sides. And when you take the square root of x squared, as we have seen in depth, the square root of x squared is the absolute value of x. And when you're solving the absolute value of x equal to 3, you're getting multiple solutions, right? Because the absolute value of 3 is 3. That's a solution. And the absolute value of -3 is also equal to positive 3. So it's also a solution. Hopefully that clarifies things a bit. Question?
So why do you get the absolute value? Like, why don't you just put x? For like,
Well, so we definitely talked about that. Is this so let's go back. Is the square root of x squared equal to x always? Yes or no? It's not, right? The square root of we saw the square root of -5 squared is not equal to -5. So that's why we have to have that. The square root of x squared has to be equal to the absolute value of x. Because, I mean, I don't know if I can offer any other justification other than it has to work that way, right? We've seen evidence that, oh yeah, the square root of 5 squared is +5, and the square root of -5 squared is +5. And that's doing exactly the same thing as the absolute value. I mean, it's really because both of these are equal to x if x is positive, and the negative of x if x is negative. And put the equal sign on either part, doesn't really matter. Yeah.
I think I'm just confused with
Okay.
the square root of 9 is always +3, then what is the -3 ever?
Well, so again, right, this equation, right, if we're trying to solve an equation, we want all the solutions. Is -3 a solution to this equation?
Yeah.
Definitely. So that's why we need to include the negative of the square root of 9 because it's a solution. We get the same sort of thing. Right, I picked an example of an actual square number, but if you were trying to solve something like x squared equal to 7, how many solutions are there? 2. And what are they? Right. And we need to write the positive and the negative because the square root of 7 itself is a positive number. And only positive, right? The square root of 7 is 2 point something. I have no clue what it is approximately. It's between 2 and 3. All right, but this number here, right? If you take out a calculator and put square root of 7, it's not going to give you a positive number and a negative number. It's only going to give you the positive number. And so we need to write a plus or minus so that we get both solutions to the equation. Good question. You guys are asking really thoughtful questions. Like this is definitely something I talk about with almost all my classes because like it's something that people have kind of like been aware of over the years, but maybe haven't always had a strong grasp of. And it's something that you kind of just go with the flow with, but really like there is a reason why we do this, and this is the reason. I could talk about this forever if you wanted me to, because I think it's really neat. But I imagine there are other things. So you're welcome to ask more questions about it. Don't stop from asking questions, but we can also move on to something else if you guys want. So, or I should say, we're going to move on to something else unless you have more questions. Oh, there's the back page here. Yeah, great, cool. Grab up back. Some other even and odd functions. So this is a time where I could graph things by hand. Maybe I should graph a thing by hand. Sure, we'll graph some things by hand. Let's look at, say, f of x equal to sine of x is, well, let's graph it and then we'll see if it's even or odd. So typically when I graph sine or cosine, I'm going to graph one period, and probably more than one period, which is a length of 2 pi. I'm going to try and make it about the same to either side. And then sine, I always think of it starting at the origin. And then there's kind of 4, or I guess 5 t points I like to graph. They occur every quarter of a period, so every pi over 2. So here's pi, here's pi over 2, here's 3 pi over 2. And then my sine graph goes as high as 1, as low as -1. That looks like this. And then that. Oh, come on. Also, right, Desmos is great. And then it does this to the left. And it's periodic, meaning it repeats itself every 2 pi. Ooh, okay, yeah, sure. So just from symmetry properties alone, does this look like an even function that has symmetry about the y-axis, or an odd function that has rotational symmetry? Odd, right? If you rotated this 180 degrees, or alternatively, if you flipped it across each axis, like the x and the y, it would look the same as it did originally, which it would. So sine of x is an odd function, which means f of -x, which is sine of -x, is equal to negative f of x, which is negative sine of x. And this is actually a fact that comes up often. And let me write it again, because I feel like I didn't write that very clearly. It is good to know that sine of -x is equal to negative sine of x. How would you prove that? You'd use the angle sum formula if you really wanted to prove it. I don't think we need to prove it, but I will just point out these formulas come up. Yeah, you definitely want to. So I'm going to talk about this formula briefly because it definitely should come up when your teachers show you, and I will also show you how to find the derivative of sine and cosine using the limit definition, which you're going to get to in a couple of weeks, maybe next week. There is this formula: sine of a plus b is equal to sine of a times cosine of b plus cosine of a times sine of b. And if you add, it's like that. If you subtract, it's like that. So sine of a plus or minus b is equal to sine of a times cosine of b plus or minus cosine of a times sine of b. If it's a plus here, it's a plus here. If it's a minus here, it's a minus here. And I guess I should mention the one for cosine as well. Cosine of a plus b is equal to cosine of A times cosine of B minus sine of A times sine of B. And the signs are opposite. If it's a plus here, it's a minus here. If it's a minus here, it's a plus there. Question?
Well, what are formulas used for?
Say that one more time.
What are these formulas used for?
They're used for a number of things. One thing we're going to use it for right now is to show that what I just said is true is actually true. In pre-calculus, I often had students use these to evaluate other interesting angles. Like so you should be aware of how to find like sine of 30 degrees or 45 degrees or 60 degrees, right? All the kind of the standard angles. But you can use this formula then if you know sine and cosine of those standard angles, you could use this to find, say, sine of like 75 degrees. Because you can write it as sine of 30 degrees plus 45 degrees. And then you can write that as sine of 30 times cosine of 45 degrees plus cosine of 30 degrees times sine of 45 degrees. Which is kind of neat. So it gives you more versatility and things. And this is probably how people actually like, probably back when they used to use like tables of angles for trig functions that you looked up what sine of 61 degrees was. This is certainly part of doing that. Question?
So you can use any numbers that add up to 75 if you know that it's 75.
Right, but the key thing here is that we want to use numbers that we already know how to find sine and cosine of. So you could use 20 degrees and 55 degrees, except I have no clue what sine of 20 degrees is. You probably don't either because it's not a standard number. Whereas you should all know, and if you don't, you should practice looking at the unit circle what sine of 30 degrees is. Sine of 30 degrees is 1/2. Cosine of 45 degrees is the square root of 2 divided by 2. Cosine of 30 degrees is the square root of 3 over 2, and sine of 45 is the square root of 2 over 2. And if you simplify this, 1 times root 2 is root 2. Root 3 times root 2 is root 6. And this comes out to be the square root of 2 plus the square root of 6 all over 4. Which some smart calculators will actually show you. Like if you put in sine of 45 degrees, or sorry, well, if you put in sine of 45 degrees, your calculator might show you it's the square root of 2 over 2 instead of saying it's 0.707, et cetera, et cetera, et cetera. And if you do sine of 75 degrees, it might actually spit out square root of 2 plus square root of 6 all divided by 4. It's kind of neat. I feel like I saw another hand over here. And if I'm also, I should just mention, if I'm accidentally covering things up, please let me know because I occasionally don't see the thing I'm doing. Other questions? But the reason, so this formula will definitely come up when we talk about how to find the derivative of sine and cosine. For sure, 100%. If not in your class, we will definitely talk about it here because you should see it. It's worth seeing.
Is this like related to like the unit circle too?
Definitely, yes. Let's all take a break because it is like 11:15. You can use the restroom if you want. I'm gonna go use the restroom, fill up my water, and we'll come back in like, I don't know, 3 or 5 minutes, whatever, however long it takes. Just because I do need to pee. And then we'll talk about how we're gonna use this formula to show that this is true. In fact, if you wanted to start, you could start by trying to start with sine of 0 minus x and use the formula if you don't feel like going into this here. I'll be right back. You should also use the recipe if you need to.
Oh, I'm like,
I should double check. I feel like I might have paused the recording and never started it back up. I'm not sure. Let's go ahead and see. Oh no, we're recording. Good. I should have paused the recording while I went to the bathroom because that would have made sense. But then I probably would have forgot to start it again. So it's probably good. All right. Wait a moment for Jonathan to get back, but we'll go ahead and here's what we're going to do. We're going to actually show that sine of negative x is equal to negative sine of x. And the way we're going to do that is by writing sine of negative x as sine of 0 minus x. And then we're going to use the angle sum or the angle difference formula is what I should really be saying. Right? It is the difference of two angles. And we're going to use that formula to do it. And like I said, I told him as I saw him, I'll wait for you. So I'll give him a moment. If you want though, you can go ahead and do it. Right? Nothing holding you back. 0 would be your A value, X would be your B value, using the minus formula, not the plus formula. This does require you to know what sine of 0 is equal to, though. If you don't know that. And cosine, you also have to know what cosine of 0 is. Also, I do crack my knuckles a lot. Hopefully that doesn't bother you too much because even if it does, I'm still going to do it. All right, Jonathan. Well, if I get going. I guess you can walk around the room and look at what you do. Yeah. All right. So we already can see that sine is an odd function just by looking at the graph of it. But if you actually want to prove it, you would do it this. And definitely showing trig functions are odd or even is probably the most challenging type of function to show already because it does require use of these angles and formulas. No one is probably ever going to ask you to actually do this. Everyone's just going to say, yeah, you can totally assume that this is true. You do not need to show it. But if you wanted to show it, here's how you do it. Say, okay, that's going to be sine of 0 times cosine of x minus cosine of 0 times sine of x. Sine of 0 is equal to 0. Cosine of 0 is equal to 1. So that's going to be 0 times cosine, which is still 0, minus 1 times sine, which is just equal to negative sine of x. And we've shown it. Sine of negative x is equal to negative sine of x. In case you don't remember what the trig functions are of 0, the easy way is to draw a quick unit circle and what I call terribly the 4 corners of the circle. I know circles don't have corners, but it's much easier than saying the 4 cardinal directions of the circle: north, south, east, and west. East, west, east and west. I always have trouble with, not gonna lie. I'm always like, east is to the right, west, yeah. Okay. Anyway, the west coast is the left coast. That's right. Anyway, so yeah, we unit circle, radius is 1. That's 1 to the right. That's 1 up. That's 1 to the left. That's 1 down. And cosine is the x coordinate value. Sine is the y coordinate value. If you don't remember, it's alphabetical. X comes before y. Cosine comes before sine alphabetically. So this angle is 0 radians. This is pi over 2 radians. This is pi. This is 3 pi over 2. This is also 2 pi radians. So cosine of 0. Oh yeah, that's the x coordinates. And sine of 0. Oh yeah, that's the y coordinates. That's how I usually think about finding sine or cosine of any of the quadrantal angles, like 90 degrees or pi over 2 or 180 degrees or pi. I will also mention calculus works best in radians. So you should get used to using radians. People will probably use degrees and radians, but specifically, like when we are graphing something, when you're graphing cosine of x, the assumption is always that your x values are in radians, right? We're not graphing degrees on the x-axis. We're graphing just there's a word I'm looking for, non-dimensional, I guess. I don't know, like degrees have are a unit, whereas radians don't really have a unit associated with them. They're kind of unitless measurements. So don't get me started, but radians are what you want to use when you're doing things. So radians don't have all the kind of, like, it's not like we're measuring feet or whatever, right? Radians don't have a unit associated with them. Yeah, okay, what time is it? 11:26, okay. I should also mention cosine. Every trig function is either odd or even. So sine, cosine, tangent, cosecant, secant, cotangent, all are either even or odd. In fact, they're all odd except for cosine and its reciprocal secant. So cosine of x looks like this. And really, when I'm graphing it, I'm thinking about my unit circle values over here. I'm like, okay, yeah, here's the whole period, cut it in half again. And at the beginning of the period, cosine is equal to 1. And at pi over 2, a quarter of the way around the period, cosine is equal to 0. And then another quarter of the period over at pi, cosine is equal to -1. And then back to 0 for cosine, and then back to the original value of 1. There's the whole period. Try to draw, if you're drawing sine or cosine, try to make it look nice and curvy, right? It shouldn't be like a straight, it shouldn't look like an absolute value, right? So I've definitely seen people draw this very kind of pointily. It shouldn't be pointy, it should be nice. And then the same graph to the left. Let's see, can I make this look nice? Probably not. We'll try our best though. Cut in half again. So yeah, we'll do it. And hopefully, arrows. You can see this is definitely even. It has even symmetry, or symmetry about, wow, that's the weirdest looking S I've ever written. Symmetry looks more like a G about the y-axis. And we're not going to show it, but you could if you wanted to. And it is true that cosine of -x is equal to cosine of x. You can see some values, right? Cosine of, say, pi is definitely equal to cosine of -pi. They're both equal to -1. So yeah, and then every other trig function also has some sort of symmetry. Secant is the only other trig function that is even. Meaning the other four are all odd. Sine, cosecant, it's reciprocal. Tangent and cotangent, it's reciprocal, are all odd. We can draw a tangent real quick as well. Tangent of x is indeed odd. And here's what it looks like. Well, here's what part of it looks like. Usually when we draw a tangent, we draw like one period of it. And it's vertical asymptotes at pi over 2 and negative pi over 2. And I mean, those aren't the only ones. It has literally an infinite number of vertical asymptotes. The ones we usually draw there, and then every other one is pi away. So the next one will be at 3 pi over 2. And tangent looks like this. It looks usually better than that, maybe, but you know, vaguely looks like this. And hopefully you can see that if you rotated this 180 degrees, it would still look the same. It's kind of neat, right? This part would rotate to be over there. This part here would rotate to being over there, but yeah, it totally does the same thing. You can show it's odd by knowing that sine and cosine are both, or sine is odd and cosine is even. If I wanted to look at g of negative x, which is tangent of negative x, tangent of a thing is just sine of the thing divided by cosine of the thing. So that would be sine of negative x divided by cosine of negative x. But sine is an odd function. So sine of negative x is negative sine of x. Cosine is an even function. Cosine of negative x is cosine of x. And negative sine over cosine is negative tangent. And negative tangent is the negative of our function. And so we just showed that tangent was odd. Kind of neat. Yeah, once you know that sine is odd and cosine is even, you can show all the rest of them are either odd or even by just using the quotient, the quotient nature, yeah, like the quotient identities about sine and cosine, secant, tangent, cotangent, cosecant. Yeah. Let's look. Wow. Sure. Let's look at some more stuff. So trig functions, you should definitely, if you don't remember them very well, you should do some brushing up because they do come up quite often in this class for sure. You want to know what all the graphs look like. You want to know how to evaluate sine and cosine for sure at the usual standard angles. But let's look at some other things. Let's look at f of x equal to 9 minus x squared, and let's graph it. So think about usual graph. I mean, you can plot points, but really, this is a parabola. It opens downwards. Some people might write it as negative x squared plus 9. That's probably the more standard way of writing it, actually. But often, if something's negative, we tend to write it later if there's something positive in front of it, just because I don't know. I don't really know why, but most people would probably write this way, even though this is probably the standard way. It's just a convention. This is downward opening. It has a y-intercept of 9, and that's also the vertex. And it has x-intercepts that are positive and negative 3. And we could find, I mean, I guess I could show the work of finding them, right? The way you would find the y-intercept, the way you always find the y-intercept for any sort of graph is by setting x equal to 0. And we're going to get y equal to 9 minus 0 squared, which is say 9. And then to find the x-intercepts, we're going to set the function equal to 0 or y equal to 0, whatever you want to say. And if we do that, we're going to get 0 equal to 9 minus x squared, and then we're going to solve it. And you can either solve this by what we did before, or you can say x squared equals 9, x equals plus or minus the square root of 9. Which is 3. We can see those are intercepts, or you could factor. 0 equal to 9 minus x squared factors as 0 equal to 3 minus x times 3 plus x. And we can see from there, the solutions are x equal to 3 and x equal to -3. And this function is also notably even. It has symmetry, right? And we could show it f of negative x equal to 9 minus negative x quantity squared, which is equal to 9 minus a negative times a negative is a positive, so it's equal to 9 minus positive x squared, which is the original function. Check. F of x equals f of x equals f of x. Oh, wow, f of negative x is equal to f of x. Question.
Is that up there says y sine? Y minus sine? I can't do that.
Right here,
Yeah.
y intercept, or y, this is y dash int.
Oh, okay, the actual x intercept.
Correct, yes.
Oh,
And let's talk about the domain and range as well. So when you talk about domain, the question you usually want to ask yourself is there anything x is not allowed to be? And the typical 3 restrictions you're going to encounter are, is there any value of x that's going to make you divide by 0? No, right? There's no division here at all. Is there any value of x that's going to make you take a square root of a negative? Or I should say really, any even root. You can't take a 4th root or a 6th root or a 1000th root of a negative number and get a real result, right? So we talked about that already, it gives you imaginary results. No square roots here, no big deal. And then the third thing you want to check is there any possibility of taking a logarithm of a negative number? Because you can't, so I should say, you can't take a logarithm of a negative number or 0. So if you don't see any of those 3 things, possible division by 0, possible square roots, possible logs, then the domain is everything. There's no domain restriction. And here there aren't any. The domain here is everything. You might write it like this, parentheses, negative infinity, comma, infinity, parentheses, or you might get fancy and write it as this R with an extra vertical line, which means the set of all real numbers. People do that because they don't want to write all this. The range, on the other hand, is limited, right? The range, we only go as high as a y value of 9. We can go as low as negative infinity, or I should say, we can go low forever. So our range here, there is no lower bound, but there is an upper bound, and we are stuck at 9. And if you don't want a parentheses or a bracket there, a bracket, so I want to include the 9 for sure. So there is our domain, our range. Sorry. Let's look at some. So
yeah. What is the R mean? Real number or what?
it means all real numbers.
All real.
Yeah, and so it would actually be. Some people do actually write it out. You could also write the words or all real numbers. That's something people also will do if it's all real numbers.
Can you use like when you say greater than or less than, you know how you can say equal to? Can you use that with infinity, or you don't use that?
You don't. So here's what I will say. Typically, if someone's asking you to write the domain or range, most of the time they're going to want you to use what's called interval notation like this. But if you were trying to write it a different way, so if I was writing the domain, yeah, so the domain, it would feel like I probably wouldn't. The domain here, it's hard to express using an inequality because we don't typically write something like that. You can, it doesn't feel exactly right, but it's not really wrong. So the domain here is a little sketch. For the range, if you wanted to write it using inequality, the way I would write the range would just be y is less than or equal to 9. There is no need to include the fact that it's greater than negative infinity, because of course it's greater than negative infinity. You don't have any choice if you're a real number. Right? If you're a real number, you are larger than negative infinity. If you're a real number, you're also smaller than positive infinity, right? It's kind of just, it is what it is, which is why it feels kind of dumb to write this. But if you don't have any restrictions and you're trying to write it using inequality, you're kind of forced to do that, but it feels silly. I wouldn't write this. I would write, the domain is all real numbers. That's what I would write if I had to. Let's look at another function. Let's look at f of x equal to the square root of, that feels fine. That feels less exciting. Square root of the same thing. So now we have some restrictions. We have some issues, domain and range wise. Let's talk about the graph though. Actually, no, let's talk about the domain range first. So when we're talking about domain, when you have a square root, the insides, or what's called the argument of the square root, has to be non-negative. So we need for 9 minus x squared to be greater than or equal to 0. So whenever I'm not thinking about domain of a function and there is a square root involved, I'm always looking at the insides of the square root, or the fourth root, or the sixth root, whatever even root, and saying, okay, I know that stuff has to be greater than or equal to 0. That's always my starting place. And then we can solve this. I would probably do it by factoring. So you can, but it's a little dicey. You could say 9 is bigger than or equal to x squared, and then square root both sides, but it's not the best. If you square root both sides, then you're going to have the square root of 9 bigger than or equal to the square root of x squared, which is the absolute value of x. And I feel like this, I mean, you can do it this way, but it's usually preferable to do something more like this. I would always recommend, if you have a non-linear inequality, which just means you have a power of x that is other than 1, 2, -1, whatever. Answer, James. It's usually best to factor. I'm going to factor this as 3 minus x times 3 plus x greater than or equal to 0. And then I'm going to put the zeros on the number line. Here's my real number line. Here's infinity over here. Right? Normally I wouldn't write that, but first time. Okay. And I'm going to put the values of x that make this quantity equal to 0 on my number line. And notably, nothing else. I don't want to include 0 unless it's something that actually makes the quantity equal to 0. I don't want anything extra. I just want the numbers that are important to me. So then we're going to determine in each interval whether this quantity is positive or negative, just by picking points. So I'm going to pick something larger than 3, like 5. I'm going to plug it in. 3 minus 5 is negative, 3 plus 5 is positive, and then negative times a positive is negative. I don't care what the number actually is. I don't care that when I plug in 5, I get -2 times 8, which is -16. I just care that it's negative. In a similar way, pick a number between -3 and 3. Pick 1 or 0, or really any number you want. Don't pick 3. You have to pick something between. Oh, holy smokes, I need to be more careful. Pick something literally between -3 and 3. You can't pick the endpoints, because if you pick 3, you're just going to get 0, and that's not helpful. So I pick 1, 3 minus 1 is positive, 3 plus 1 is positive, and positive times positive is positive. And then if you pick something less than -3, like -4, 3 minus -4 is positive, 3 plus -4 is negative, and a positive times negative is negative. I want this quantity to be greater than or equal to 0. So I want the parts where it's positive. I also want the parts where it's equal to 0. So my domain here is everything from -3 to 3, inclusive of the endpoints, and nothing else. And we can see that, right? If you put like x equal to 4, 9 minus 4 squared is 9 minus 16, which is -7. We can't take the square root of -7 and get a real result. So it's not in the domain. In a similar way, -4 is also not in the domain, because -4 squared is still +16, and 9 minus 16 is still -7, which we can't take the square root of. So there's our domain. Range is probably easiest to see if we graph the thing first. I suppose we could, so let's say we didn't want to graph it first, though. When you're talking about a square root, well, first of all, what kind of numbers do we get when we take the square root of something? Thank you. I was like, my question is not very good, but I think we'll get there anyway. Yeah, I feel like I could have phrased it better. Right. When you take a square root of something, you get a positive number, or you can also get what not positive number? 0. Right, 0 is not positive. It's also not negative. It's the only number that is neither positive nor negative. And it is something you can get also, right? The square root of 0 is equal to 0. So when you take a square root of something, you always get non-negative results, meaning our range has to be non-negative, right? You can't get anything smaller than 0. Can you get 0? Is there a value of x that's going to make this function equal to 0? For sure, right? So 0 is definitely the bottom of the range, right? So the smallest the square root of 9 minus x squared can be is 0. And that's going to be when x equals plus or minus 3. Okay. Sometimes I just write things that looks like absolute trash. To make the square root of 9 minus x squared the biggest, well, if I have 9 minus something, to make that quantity as large as possible, the thing I'm subtracting should be as small as possible. What's the smallest x can be? I should say, what's the smallest x squared can be? That's going to make the whole quantity. So you're answering the question that I'm accidentally asking. That's going to make this whole thing the smallest. And now I'm trying to make it the biggest. But what I was saying is to make it the biggest, I have to make the thing I'm subtracting right there the smallest. And the smallest x squared can ever be is what? 0. So if x squared is 0, that's when x is 0, then I'm going to get the square root of 9 minus 0, which is positive 3. So that's the biggest this function can be, is 3. And I can get every value in between. So my range is 0 to 3, which we also could have seen if we graphed it. So if we graph this, trying to do a decent job here. If x is negative 3, we get 0. If x is negative 2, we get the square root of 5, which is okay, fine. 2 point something. Yeah. If x is negative 1, we get the square root of 8. And then if x is 0, we get 3. And then it looks the same over here. Also an even function. What does that look like? Looks like a semicircle. Well, it is a semicircle. And you might see that more easily if you actually write this as, here, if you look at this as y equal to the square root of 9 minus x squared, if you square both sides, you get y squared equal to 9 minus x squared. And if you bring the x squared over, you get x squared plus y squared equal to 9, which is the equation of the full circle of radius 3 centered at the origin. We don't get the bottom half though, because like we've said numerous times, when you take a square root of something, you only get out non-negative values. So we don't get y being negative, we only get y being positive or 0. All right. Let's see. I suppose I should do that. How much time? We don't have very much time. I think, yeah. Let's look at one more example. Let's look at. I want to do all the examples, but time is fleeting. Let's look at this one more example. We look at 1 over the square root of 9 minus x squared. It's going to have a very similar domain, but not quite the same. So here's the domain. We now need 9 minus x squared to be greater than 0. And we actually don't want it to equal 0, because if it was equal to 0, we'd have the square root of 0, which is 0, but we'd be dividing by 0, which is not allowed. I want to make that really clear, so everyone's like, we cannot divide by 0. So 1 divided by 0, nope. Doesn't work. Or really anything divided by 0. So when you have a non-zero number divided by 0, typically you get something that is infinitely large, or is going in the direction of things. I will mention, this is going to be a vital component of this class. When you have 0 divided by 0, it is also undefined, but it's specifically what's called indeterminate. Meaning, it can take on any value. So you see 0 over 0, it's not 1, except sometimes it is. But it's not specifically 1. It could be 5, it could be 17. And I want to make this really super freaking clear, because it's really a lot of what you're going to be doing for the next couple of weeks. You're going to be doing a lot of limits that are what we call the 0 over 0 type. And so I just want to be super extra clear. If I did 0 divided by 0, how many times does 0 go into 0? Sure, that's a correct answer. What else? How about 7? Does 0 go into 0 7 times? Sure does, right? 7 times 0 is 0, 0 minus 0. Oh, yep, totally works. Right, but I want to make it, right, and we laugh because it is funny, but also I want to make it really clear, right? 0 divided by 0 could literally be anything you want it to be. you can make up any sort of fraction that's a 0/0 type that's going to come out to be what you want it to be. A kind of classic example, I know I've kind of forgotten about this. A classic example is something like x squared minus 9 over x minus 3 when x is equal to 3. I don't want to say when x is 3. So I was also looking at what he goes, sorry, Professor Molassi's homework. He's got this whole like x squared minus y squared divided by x minus y thing. Hopefully some of you maybe looked at it. If you haven't. And he talks about x equaling y, which is it's not really technically right. But what I want to say is when x is approaching 3. Well, we can factor and cancel some stuff here, right? This is equal to x minus 3 times x plus 3 over x minus 3. And those x minus 3's can cancel. And this is equal to x plus 3, as long as x isn't actually equal to 3. But if x is really, really close to 3, what's x plus 3 really, really close to? Right. So as x gets close to 3, x squared minus 9 over x minus 3 gets close to 6. One second. This is.
Wait, I still have class right after this.
Oh, sure. Yeah, and we are out of time. Yeah. So I will say you are welcome to leave right now. Go ahead, pack up your stuff. I just want to say 2 words, which are this is the idea of what's called a limit. And we're definitely talking more about it as we move on. But the whole idea here is this is a 0/0 type of form, because as x is getting close to 3, you're getting a 0 divided by a 0. And this is kind of the idea that 0/0 can be anything. In this case, it's 6. All right, I'll stop. Nice meeting all of you. I'm looking forward to class next week. I'll see you all on Tuesday, where we will do more. Also, there was one other thing I want to say just about class in general. If you have things you want me to talk about, you should definitely let me know. The best way to do that would be to write a discussion in Canvas.